टू माय चैनल। और आज पूरे दिन 13 वीडियोस आएंगे जिसमें हम पूरा HLD कवर करेंगे। और ये HLD में हम सारे टॉपिक्स कवर करेंगे एंड टू एंड। और उसके लिए कवर करने के लिए मैंने बनाए हैं नोट्स। तो ये सारे नोट्स मैंने खुद बनाए हैं और ये नोट्स मैंने बनाए थे 2022 में। कोडिंग निंजास करके प्लेटफॉर्म है, उनके लिए उनका पूरा कोर्स मैंने डिज़ाइन किया था। तो मेरे पास ऑब्वियसली ये सारे नोट्स हैं, और क्योंकि सारे नोट्स पूरा कंटेंट मैंने बनाया था तो आपको कोर्स ख़रीदने की भी ज़रूरत नहीं है। यहाँ पे मैं सब कुछ कवर करने वाली हूँ और हम सब कुछ रिवाइज़ करने वाले हैं, सारे 13 टॉपिक्स। और हर टॉपिक में और सब टॉपिक्स हैं और ये सारे टॉपिक्स बहुत इंपॉर्टेंट हैं। जैसे आप देख सकते हैं कि डेटाबेस के कितने सारे टॉपिक्स हैं, कितनी सारी स्केलिंग स्ट्रैटेजीज़ हैं। तो हम सब कुछ कवर करने वाले इंटरव्यू पर्सपेक्टिव से हर एक टॉपिक। तो आज हम स्टार्ट करते हैं फ्रॉम इंट्रोडक्शन। तो HLD इज़ हाई लेवल डिज़ाइन एंड LLD इज़ लो लेवल डिज़ाइन। LLD ऑलरेडी कर चुके हैं, 10 डिज़ाइन पैटर्न्स भी कर चुके हैं और 2 यूज़ केसेस भी कर चुके हैं और यूज़ केस करते रहेंगे स्टार्टिंग फ्रॉम दिस वीक। बट आज करने वाले हैं HLD। और HLD में आज इंट्रोडक्शन में 2 टॉपिक कवर करने वाले हैं। एक तो सिस्टम डिज़ाइन क्या है और एक HLD और LLD के बीच में डिफरेंस क्या है। तो स्टार्ट करते हैं। तो यस, तो व्हाट इज़ सिस्टम डिज़ाइन? सिस्टम डिज़ाइन इज़ वन ऑफ द मोस्ट क्रिटिकल स्टेप्स इन सॉफ्टवेयर डेवलपमेंट। सॉफ्टवेयर डिज़ाइन अफेक्ट्स ऑल significant steps from software implementation to its deployment। तो जैसे इसमें बताया हुआ है कि सिस्टम डिज़ाइन एज द वर्ड सजेस्ट, सिस्टम डिज़ाइन मतलब किसी भी सिस्टम को डिज़ाइन करना। एंड दिस इज़ सॉफ्टवेयर डेवलपमेंट लाइफ साइकिल SDLC, विच इज़ वेरी इंपॉर्टेंट, विच इज़ जनरली आस्क्ड, जिसके अंदर एंड टू एंड एक सिस्टम स्क्रैच से बनाने से लेके उसको टेस्टिंग, बिल्डिंग, डिप्लॉयमेंट तक क्या क्या स्टेप्स जाते हैं वो हमारे सॉफ्टवेयर डेवलपमेंट लाइफ साइकिल में बताया होता है। तो फर्स्ट सबसे पहले रिक्वायरमेंट एनालिसिस होती है, जिसमें 2 टाइप की रिक्वायरमेंट्स होती है, फंक्शनल रिक्वायरमेंट्स एंड नॉन फंक्शनल रिक्वायरमेंट्स। आफ्टर द फंक्शनल एंड नॉन फंक्शनल रिक्वायरमेंट एनालिसिस वी डू प्लानिंग, एंड आफ्टर प्लानिंग द मोस्ट इंपॉर्टेंट स्टेप इज़ HLD। तो पहले हम HLD करते हैं सिस्टम की, विच इज़ हाई लेवल डिज़ाइनिंग, एंड उसके बाद वी डू द LLD की सारी एंटाइटीज़ कैसे होंगी, क्लासेस क्या होंगी, क्लास के स्ट्रक्चर क्या होंगे, कौन से सॉलिड प्रिंसिपल यूज़ करने वाले हैं, कौन से की मेट्रिक्स हमारे प्राइम इंपॉर्टेंस के हैं, जैसे स्केलेबिलिटी, एक्सटेंसिबिलिटी, फॉल्ट टॉलरेंस एक्सेट्रा। एंड हमारे डिज़ाइन पैटर्न हम कौन से यूज़ करने वाले हैं, जैसे सिंगलटन बिल्ड डिज़ाइन पैटर्न, बिल्डर डिज़ाइन पैटर्न, स्ट्रैटेजी, ऑब्जर्वर, फैक्ट्री डिज़ाइन पैटर्न, कमांड, अडेप्टर, चेन ऑफ रिस्पॉन्सिबिलिटी, डेकोरेटर। तो वो कौन से हम यूज़ करने वाले हैं वो हमारे LLD में डिस्कस होते हैं। उसके बाद एक बार आपका HLD हो गया, उसका रिव्यू कंप्लीट हो गया, रिव्यू साइकिल होगी, एंड आफ्टर योर LLD इज़ ऑल्सो फाइनलाइज्ड एंड लॉक्ड वी स्टार्ट विद बिल्डिंग। एंड जनरली दिस इज़ अ मिसकंसेप्शन दैट सबसे ज़्यादा अमाउंट ऑफ टाइम इन सॉफ्टवेयर डेवलपमेंट गोज़ इन टू कोडिंग। नो, दैट इज़ नॉट करेक्ट। Most of the time goes in designing, in creating the high level design and the low level design, and also the requirement gathering. After that, in this building we do the coding, and this is code heavy step. And after that we also have to do testing. Now there are different types of testing which we will also cover in this course only later, like unit testing. And after you have tested, you might have found all the alpha bugs, all the testing bugs during testing, you will fix it. And after that it goes into deployment, where you deploy it and it is available for the end customer to use. So this is how a software is built from scratch to deployment, means how it is handed over to the customer as per the requirements from the customer. So this is what system designing is. It is the process of creating the architecture of different components, interfaces, modules of system, and providing it with data helpful in implementing of the system elements. So system designing is nothing, it is the process of creating your system, which creating a system we can call it as creating the architecture of different components of your system and how they are going to interact, providing with all the important data which is helpful in system element designing. It is a way towards characterizing, creating planning frameworks that fulfill the necessities and prerequisites of a particular business or association. It is the stage where SRS report is changed over into a component division architecture that can be executed and decides the resulting framework execution. So this is where your SRS. So let me tell you what SRS is. SRS is software requirement specification. So after this first step, which is requirement analysis, we create a software, we create a report, and that report is called SRS, which is very important. This is a very important term. The full form of SRS is software requirement specification. सो एक बार आपने रिक्वायरमेंट एनालिसिस कर ली, उसका एंड क्या होगा? आपने सारी रिक्वायरमेंट्स गैदर कर ली, फंक्शनल रिक्वायरमेंट्स गैदर कर ली, फंक्शनल रिक्वायरमेंट्स और नॉन फंक्शनल रिक्वायरमेंट्स आपने गैदर कर ली. फॉर एग्जांपल जैसे यू आर क्रिएटिंग अ रेस्टोरेंट मैनेजमेंट सिस्टम, तो उसमें फंक्शनल रिक्वायरमेंट्स क्या होंगी कि कस्टमर शुड बी एबल टू बुक द टेबल, दे शुड बी एबल टू ऑर्डर फ्रॉम द मेन्यू, दे शुड बी एबल टू पे. एंड नॉन फंक्शनल रिक्वायरमेंट्स क्या होंगी? डेटा कंसिस्टेंसी होनी चाहिए. फॉर एग्जांपल ऑर्डर शुड बी डिलीवर्ड ओनली टू द पर्सन हु इज ऑर्डर्ड इट एंड नॉट टू समवन एल्स. तो मैपिंग करेक्ट होनी चाहिए. तो ये सब उसकी नॉन फंक्शनल रिक्वायरमेंट्स हो गई. एंड नॉन फंक्शनल एंड फंक्शनल रिक्वायरमेंट्स आर बोथ suggested by the customer, they depend on the use case, and the person who is working on requirement analysis from the software team and the customer, they sit together with meetings, they come to this end common ground and create this report, and the end point and the end result of requirement analysis is called SRS report, which is software requirement specification. Means you've specified all the requirements gathered in this first step in this report. Okay, and this is the input criteria which is reviewed by your HLD. So we have known that after requirement analysis goes the end result, which is SRS report, that goes for planning, and in this planning we do the HLD. So in LLD and HLD, they are both different levels of detailing, and HLD is done first. HLD output is the input of LLD. HLD's output is the input of LLD. So this is a chain. So let's look at various phases of SLDC, SDLC, software development life cycle, which is requirement, then we do HLD, then we do LLD, then we design it. This is designing, then we build it. After building, we do the testing and the deployment and hand it over to the customer. So the systems are as follows. First is the requirement analysis. So functional and non-functional requirements are collected by interacting with the stakeholders, with the users. So generally customer is not a professional term in terms of requirement analysis, because there is no single customer. For example, a company might be asking for a product. For example, we are a service based company, so there is no single customer. The term that we will be using forward also in the next lectures and also in interviews will be stakeholders, because these are the people with interest in the product that is being built. So they are going to shape the requirement analysis step. So functional and non-functional requirements are collected by interacting with the stakeholders and users with different requirement elicitation techniques. Now there are many kinds of techniques, requirement gathering techniques, which is not of much use. And after that goes into planning or analysis. So this requirement specification, SRS, the software requirement specification report, that is defined, it is documented, we plan the task. For example, planning the ETAs. ETAs is estimated time of arrival, which is the deadlines of each task, that this is the first step, these are the components which will be ready by this date, and so on. So that is done. And also I forgot to mention that in requirement elicitation techniques, what do we mean by this? That the stakeholders or the customers and the software person, they sit together and they ponder over what the requirements of the final system are going to be. For this, there are many elicitation techniques. For example, interviews. So there can be direct conversation with the stakeholder to understand their needs and expectations. So this can be a one-on-one, or there can be focus groups working on different components of the system. Some other famous elicitation techniques are brainstorming. So this is kind of a group activity where the stakeholders come and the software team comes, engineers come, and they brainstorm, generate, refine all the requirements through open discussions and idea generation. This is called brainstorming, which is a very common term in corporate. Then comes observation. So observing users in their natural work environment to understand their task and potential requirements. For example, if my customer is Samsung, so we know that they make majorly heavy transistor heavy chips. So I know that they are going to require whatever they are going to require, the like priority in the requirement is going to be high runtime, like very high speed. So these are some of the examples of requirement elicitation techniques. Like we've talked about interviews, brainstorming, document analysis. We can also go for surveys or questionnaires and workshops. After these are all physical or online. And after that we go into system designing. So we have planned, we have analyzed, we have gathered the requirements, we have created the SRS report. We are now going to get into architecture. This architecture of the system and its component, they can be of two types, HLD or LLD. First we are going to do HLD, then we do the LLD, and later on we move on to the implementation or coding part. The software is now built using suitable programming languages and technologies, and after you have built the system, obviously you are going to test it for any bugs or whatever the use cases customer has provided, the scenarios customer has provided, and after that we go into development. So here in development, the software is prepared for release. So there are release cycles that we know that this is the build that customer is going to use, and it gets deployed or maintenance. Now testing techniques, that also we will be learning in the next future lectures. And some of the common functional testing techniques are unit testing, which we all use. For example, you have created a lot of components, so every component first you're going to isolate it and then test it. This is called unit testing. Then there is integration testing, where we test the interaction between different modules and components of your system together. So unit is only one component, but integration is throughout. So we test the flow, we test the interaction between different modules. One is system testing, where we test the entire system. And then there's acceptance testing. So we have already created the SRS. We test if all the requirements suggested by the stakeholders or the users is met by our system. So these are four types. One is unit, we test the system. Then integration, we test the flow. And then system testing, where we test the entire system. Now system designing is the backbone of software development, obviously, because this is one of the steps that comes into effect at the very initial stage. So if you check the SLDC, there are total 6 steps, and the first and the third step exactly is designing. So if we do some mistake here in the third step, or the designing is not done correctly, all the steps after it, building, testing and deployment, are going to get directly affected. And therefore this is the backbone of software development, because the major part, like how the system works, is the coding, or where you're going to implement or build your system, and that directly proportionately depends on your design. So system designing is the backbone of software development, and all the further steps directly depend on the design prepared. It is crucial for any person indulging in software development roles to understand and master them, and system design is also frequently asked in interviews. So this is why we are going to prepare. We are not going to this will also come handy when we work in any corporate company, but this is a major reason, like this is the reason for my course. And the system design involves identifying the sources of data, nature, type of data, etc. This is all like selecting or choosing what type of database we are going to using, what type of rate limiting we are going to use, what scaling technique, what load balancers. Everything will be decided during high level designing of your system. For example, in order to create a salary calculation app, there is a need to use inputs such as attendance, leave details, additions or reductions. This helps to understand what kind of data is available and who provides it to the system, so that the system can be designed taking into account all relevant factors. So this is where we do requirement elicitation. Now we have understood the significance of the subject. So there we have understood how significant and important system designing is, and system designing is actually the backbone of software development. So what is the objective of system design? It is practicality. So system designing is crucial in making a system that suits the need of the target users in real-time scenarios. Obviously, when we design a system, we want it to be practical, and therefore we do system designing to check and to measure how practical that system is. Then correctness, the system must satisfy all functional, non-functional requirements mentioned in the SRS. And completeness, so the system should be complete in all terms from components to functionality specified in the SRS. In addition, system design leads to ensuring that the system is designed that meets the needs of users and makes it user oriented. Now efficiency, our system should be resource effective, neither surpasses the cost nor fails to deliver any functionality. Another important goal of system design is concerned with creating a more efficient system to provide the required output and response time within the allocated time. So your system design section ensures the safety and efficiency of the system also, because we already know what effort will be going into system. Once you created the high level design, we can give a good effort estimation also. Now moving on to the flexibility. So flexibility is one of the most important parameters currently for any system, because we want our system to be flexible, that we want to change the requirements mid project or after the project. We want to make it scalable. So our system should be able to adapt to those changing needs of the user. And the other objectives of this phase is to to build such a system that can be environmentally friendly, respond to changes if necessary, without lot of cost. So it should be able to adapt with least cost possible. And optimization, so these are some of the topics, terms that we will study in detail in the next lectures, which is latency and space. And we want that our system should have low latency, means it should be as fast as possible. And our system designing helps to make sure that our system is reliable and it is fault tolerant. So this term also, this is an important term which you are going to learn in the next lectures. So fault tolerance means that your system keeps operating even when there is any fault. So tolerance means gracefully handles any fault. And what are the advantages of systems design? So awareness of full stack of computer science, efficiency increasing, speedy software development process, fewer mistakes, because it saves time and resources. The actual procedure therefore saves resources, simpler and uncomplicated, reducing designing cost. Also, all these notes that I have created, I have went through so many online resources and then created this gist or summary. So this is extremely effective for like quick revision and covering all essential topics. So therefore these notes are very important. I'm going to cover these notes only in these courses, and they will cover all the topics, 100% of all the topics. Now moving on to the next topic in the same video, which is HLD versus LLD. So system design architecture can be depicted as HLD or LLD. We have seen in the previous document that system designing is the process of architecture of your system and its component. So system designing can be of two types, HLD or LLD. HLD is done first, LLD is done next. So HLD and LLD, what is the difference that we are going to study in this document. So HLD, this is the kind of architecture that takes into consideration the main components that would be developed for the resulting product. The designer only focuses on high level overview like principal components, databases, what are the services, microservices, relationship between modules and component, whereas low level design, this is very contradictory to your HLD, because HLD focuses on only architecture of the high level or main components, like what database you are going to use, what are going to be all the different microservices, their interaction between different modules or components. Whereas LLD, this kind of architecture, this goes deep. This considers the in-depth, detailed designing of your complete system and each component which is mentioned in the HLD of the system. It exposes the logical relationship between the different elements and a detailed description of all the modules, and this includes more technical information than your HLD. So HLD is not technical, but LLD is technical. It also includes OOPS concepts. And LLD includes a description of the components. For example, it includes the UML diagram. So we have seen these are 3 types of UML diagram: class diagram, most common ones; sequence diagram, this is also important for understanding the relationship between classes; and activity diagrams, not much used. Then information about the platform, algorithm, design pattern used, this we have seen in a lot of detail. Solid principles which are used, relationship between modules and system, hardware, software interface, etc. Let us see with the help of an example. Suppose RAM wants to create a social media app. The high level design will consist of an overview of system like mobile app for iOS, Android, an app for OS X or Windows, web GUI, SQL, NoSQL database. In contrast, a low level design would consist of each user application is logically linked to other modules and all the extra details of each component mentioned in HLD that's useful and necessary before developers can start writing the code directly. So LLD will be directly used by the coders, but HLD will be used in creating the LLD, because HLD will mention all the components. LLD will in depth do analysis, technical analysis of each component and break it down and create it. Let's try to design a cab booking system like Ola or Uber. An application like this has extensive design functionalities involved. Yes, this is an extensive design. So let's try designing one. First, we understand the functional and non-functional requirements. So functional requirements, let's see that we want the nearest cab availability. We want to book a cab. We want to do fare calculation and payment and GPS tracking of the cab also for security reasons. Then non-functional requirement is we want it secure, because whenever we payment services involved, security and fault tolerance comes hand in hand. Then reliable, it should be reliable and scalable. It should be consistent. Less response time means low latency. So high level designing would consist, so we have done, this is the SRS, system requirement specification report. After this, we do the high level designing. In high level designing, we would mention and consist of all the major components. It will consist of like car details, customer details, booking details, price details, payment details, car insurance details, and map service. The admin application would consist of a cab request service and a cab finder service. Also remember, the live location of the driver is always shared with the system. This can be managed by a tracking module which is called the location service. The trip completion event would be managed by a payment service which would calculate the price on the basis of distance covered and the rate per distance covered. High level design would include a brief description of each functionality like user login, checking credentials, etc. Low level design would be more detailed. It would be the description of your HLD only, like how the payment gateways will be linked, detailed map service, what are the private classes, data members, private methods, data structures, inheritance, design patterns, solid principles, etc. So let's see the table which is summarizing the difference between HLD and LLD. So firstly, the differences, their full form or their abbreviation. HLD is called high level designing, LLD is called low level designing. There are some other terms also. HLD is also called macro level designing and LLD is also called micro level designing. HLD is also called normally system designing and LLD is also called detailed designing. Whereas the input for HLD is your SRS, which is system requirement specification, whereas LLD is your HLD, which is high level design. The definition. So HLD is the architecture of the main components of the system, whereas LLD is the designing of detailed designing and technical designing of every component of your element mentioned in the HLD. So the system architecture details database designs, the services, processes, microservices, modules, features, whereas LLD has the classes, interfaces, relationships, and actual logic of various components. Also, chronological order, if we see, so HLD is created first, LLD is created after HLD is completed, and technically if we see, then HLD is less technical but LLD is more technical, and the target audience for HLD is your management or your product manager, whereas LLD is used by the coding team. So I hope this was helpful and we have covered the introduction of HLD and LLD. If you want these notes, please leave a comment in the comment section. Thank you.